So here we are in video number 3. We realized that if we ever need to evaluate a limit, the very first thing we should do is do direct substitution of the x value that we're approaching. If we get a finite answer, that's the limit value and you're done. But something happened on this situation on letter F. We substituted the 2 and we didn't quite get a finite answer. Actually, we got an undefined value. So we're going to talk about what that means. Not only that, in this next example, we're going to substitute 4 and see what we get. All right. By the way, whenever there's a limit of a fraction, it's going to be necessary, I'm going to say, in order to get full credit, to separate that into the limit of the numerator, the limit as x approaches 4 of x squared minus 3x minus 4, and take the limit of the denominator, the limit as x approaches 4 of x squared minus 9x plus 20. Whenever there's a fractional setup, we should do that. And I should have done that in letter F as well, but I didn't. And I apologize for that. But everything else, and for letter D as well. So here, when we're taking the limit of a ratio, there's a property that says we can take the limit of the top, get an answer, take the limit of the bottom, get an answer, and then put the answer of the numerator over the answer of the denominator. Well, when I do this limit, and if I substitute a 0 wherever I see, I substitute a 4 wherever I see a 0, wherever I see an x, let's see what we get. So 4 squared, that's 16, minus 4 times 3, that's 12. So 16 minus 12 is 4, minus another 4, well, we're going to get 0. And if I do the same thing in the numerator, in the denominator, and I substitute 4 wherever I see an x, that's going to be 4 squared, which is 16, minus 4 times 9, which is 36. So 16 minus 36 is negative 20, plus 20, that's 0. And now I have a problem, because I cannot divide 0 divided by 0. I can't. You can try it in your calculator, you're going to get an error. And the reason why we can't is because this produces what is called an indeterminate form, 0 divided by 0, an indeterminate form. And if you think about what a fraction tells us, remember that a fraction tells us that it's something out of a whole, right? So if the denominator is getting smaller and smaller and smaller, the fraction as a whole is getting larger in size. But if the numerator is getting smaller and smaller and smaller, going to 0, then the fraction as a whole is getting smaller in size. So when we have 0 over 0, we can't determine what's going on, and we have to try something else. One of the things that I'll connect this back to, I think we talked about it in a pre-cal class, was that whenever you have 0, 0, that's a clue that there might be a point discontinuity. There might be a hole in the graph. And so as we plugged in x equals negative 2, what did we get? We got an indeterminate form. Now, there's different types of indeterminate forms, but the two main types that you're going to see on the AP Calculus exam are 0 over 0, which we just saw. There's another type, infinity over infinity. And very much like the case of the 0 over 0, when I treat infinity over infinity, if the top is getting bigger and bigger and bigger, the fraction as a whole gets bigger. But if the denominator gets bigger and bigger and bigger, then the fraction as a whole is getting smaller. So if two things are happening, they're kind of fighting each other, and I can't determine what's going on. That's how we get indeterminate forms. So the big idea here in video 3 is, what do we do when we get an indeterminate form? So there's different techniques you can use. We're going to do one technique here on this video called factoring, and then we'll do another technique in the next video and the last video called rationalizing. But in the factoring part, it's exactly what we mean, what it says. We're going to factor and see if we can figure out what's going on. Now, to begin with, I am going to check. Remember, whenever we have a fraction, a rational setup, there's a top and a bottom. We should take the limit of the top over the limit of the bottom just to see if we get 0 over 0. Try not to, and by try I mean please don't, just put 0 divided by 0, because you will not get full credit on the exam. So they're looking for you to apply the property that says when I'm taking the limit of something over something, a ratio, That's the same thing as the limit of the top, so you got to show that, over the limit of the bottom, right? And so we're going to break it up into two pieces. If you substitute 4, you are going to get 0 over 0. That's what we got, and that was the same example we had over here, right? Where did it go? There it is. That's the same example that we had over here. Okay, so what we're going to do is we're going to try to factor. And so we're going to take the same limit, but this time, as x approaches 4, we're going to factor the numerator and we're going to factor the denominator. So if we factor the numerator, x squared minus 3x minus 4 can be factored as x minus 4 and x plus 1. Right? If I unfoil or if I undistribute that, that's going to give me the factored version of that quadratic expression in the numerator. And if we do the denominator, it's going to be x minus 4, x minus 5. Well, what do you notice about this setup? The top and the bottom both have a factor of x minus 4. So we can reduce that out. And when we reduce that out, we can take the limit again to see if it exists. So once again, I'm going to break this up into take the limit as x approaches 4 of x plus 1, and take the limit as x approaches 4 of x minus 5. Because if we get an answer that's not 0 over 0 here, then that is our actual limit value. So for the top, if you substitute a 4, you get 5. In the denominator, if you substitute a 4, you get negative 1. And so therefore our answer is 5 divided by negative 1, or negative 5. This is the actual limit value. Even though at the beginning, when we did the limit, and we saw it in the previous example, we got 0 over 0, right? We got an indeterminate form. But indeterminate forms when you get an indeterminate form, it doesn't mean that the limit doesn't exist. It means we have to try something else. And one of the things you can try is this factoring business. Now, I will point something out. It's not a coincidence that the x value that I was approaching is related to the factors that were eventually reduced out. There's a reason, right? Because when I plug in 4 into this top factor, I'm going to get 0, and 0 times anything is 0 on the numerator. And when I substitute 4 in this factor, I'm going to get 0, and 0 times anything is 0 on the denominator. So if you have an issue, if you have trouble, like how do I start this factoring? Well, look at the x value that we substituted that produced the 0 over 0 situation, and use that to help you build the first factor. And let's see if we can do that over here. Oh, my Lanta, look at that. All right, so just to make sure, we're going to take the limit as x approaches 0 of the top. This is showing whoever's grading your test that you understand that there's a property that says if I'm taking the limit of a fraction, of a ratio, I can take the limit of the top, I can take the limit of the bottom separately, and then bring those answers back. But I got to separate them. When I substitute 0 on the top, I'm going to get 0. When I substitute 0 on the bottom, I get 0. And that is 0 over 0. And that doesn't work, right? That's an indeterminate form. So that means I can factor something. What can I factor? Well, this tells me the factor has to involve 0 somehow. And when I look at my expression here, I realize, oh, the two terms in the numerator have an x squared in common. So I can factor out an x squared. That leaves me with 4x minus 5. And the terms in the denominator expression have an x squared in common, so I can factor out an x squared. And I'm left with 6 plus 8 times x to the third. So it's not that I'm binomial factoring, I'm just factoring out the greatest common factor. Like, what do they have in common? And just like that, I now see, oh, I can reduce these x squares and I can try it again. I can substitute the 0 into the numerator. I can find the limit as x approaches 0 of 4x minus 5. What is that? If you substitute that, you're going to get negative 5. And I can substitute the 0 into this now simplified denominator. And if you substitute that, I think you get 6. So therefore, my answer is negative 5/6. This is the limit. There was probably no way if I graphed this that I'd be able to see that that's the y coordinate that this function is approaching as x approaches 0. But analytically, algebraically, we can figure it out. So the moral of the story is if you get a 0 over 0, that's an indeterminate form. One way to get to solve it is to try a technique called factoring and just factor it out and reduce, and whatever's left over, try the limit again. And if you get an answer, that's the actual retail price.